Unit 4B, Lesson 3. In this lesson, we're going to work with analyzing data. We're going to have a control group and a treatment group that has one difference, one variable. We're going to be given a table of data with some information about the control group and the treatment group and try to determine whether that one change, that one variable, is significant or not. So now to our first example. Psychologists had a hypothesis that meditation reduces work stress. Work stress is commonly measured by the psychological strain questionnaire, the PSQ. The higher the PSQ score, the less stress the subject feels. They randomized 200 full-time employees between a treatment group and a control group. The treatment group was instructed to meditate for about 15 minutes twice per day over a period of 8 weeks. The subjects' PSQ scores were gathered just before and right after the treatment period. The results of the experiment showed that the mean change in PSQ scores of the treatment group is 15 points greater than the mean change in PSQ scores of the control group. To test whether the results could be explained by random chance, the researchers created the table to the left, which summarizes the results of 1,000 re-randomizations of the data, with differences between means rounded to the nearest 3 points. According to the simulations, what is the probability of the treatment group's mean being higher than the control group's mean by 15 points or more? Assume that if the probability you found is lower than 5%, then the result should be considered significant. This might be a good time for you to pause the video and read that information for yourself because I'm not going to read it again. So we had this situation of stress in the workplace. They had an idea to try to help reduce some of that stress by meditating twice per day for 15 minutes. So we have our control group and we have the treatment group, which is going to meditate. And then we had results that the treatment group was less stressed after those 8 weeks due to the meditation. Now what we're trying to do is determine whether those results were based on the meditation or if it was based on the randomization of the groups. Maybe some of the people, a majority of the people in the treatment group are naturally less stressed than a majority of the people in the control group. We don't have any way of knowing that, so we're going to re-randomize all of that data 1,000 times and then analyze the frequency of those results to try to determine whether or not the results are significant, whether the meditation helped, or if it was due to the randomization of the groups. So what we need to do is go to our table. In the first column, we have this value of the treatment group mean minus the control group mean. So we have the results from those that meditated versus those that don't, the difference in their scores on that test, that questionnaire. And then we have the frequency, how many times that score, that difference occurred out of the 1,000 re-randomizations. What we're going to focus on is the scores, the differences that were 15 or more. So 15, 18, or 21. We can see that difference of 15 occurred 23 times out of 1,000, 18 occurred 7 times out of 1,000, and 21 occurred 3 times out of 1,000. So if we add up all these frequencies, 23 plus 7 is 30, 30 plus 3 is, there were 33 out of 1,000 of those re-randomizations of the data where the difference between the score of the treatment group and control group was 15, where the treatment group scored at least on that questionnaire 15 points or higher compared to the control group. If we convert that to a decimal, that would be 0.033, which as a percentage would be 3.3%. So at the bottom of our information, we saw that assume that if the probability you found is lower than 5%, then the results should be considered significant. So we found our results, the probability to be 3.3%, which is less than 5%, which means our results should be significant. That means the meditation actually helped reduce stress in the workplace on those employees that were in the treatment group. It wasn't simply due to the randomization of the people in each group. We're going to go through one more example, very similar to the last one, because after reading all this information, I'm not going to want to go through a third example. Researchers had a hypothesis that wearing socks over boots decreases the sensation of slipperiness when walking down an icy road. 320 volunteers were randomized between a treatment group and a control group, and both groups were asked to walk downhill on an icy road. The control group simply wore boots, while the treatment group wore socks over their boots. Once downhill, the participants indicated how slippery the descent felt on a scale ranging from 1, not slippery, to 5, extremely slippery. The results of the experiment showed that the mean slipperiness score of the treatment group was 1 point less than the mean slipperiness score of the control group. To test whether the results could be explained by random chance, the researchers created the table below, which summarizes the results of 1,000 re-randomizations of the data, with differences between means rounded to the nearest 0.2 points. According to the simulations, what is the probability of the treatment group's mean being lower than the control group's mean by 1 point or more? Assume that if the probability you found is lower than 5%, then the result should be considered significant. So just like I said in the last example, you should probably pause and read this information again for yourself, and also try to say the word slipperiness, because it's not as easy as you would think. For this problem, we want to determine the probability of the treatment group's mean being lower than the control group's mean by 1 point or more. So we have, again, our treatment group mean minus the control group mean, and how many times that value, that difference occurs out of 1,000 re-randomizations. The data we're going to focus on is this top portion, because we want the score of the treatment group mean to be at least 1 point less than the control group mean. So now we add up all these frequencies. 2 plus 11 is 13, plus 16 is 29 out of 1,000 re-randomizations, which as a decimal is 0.029, and as a percent would be 2.9%. Like the last problem, if we assume that the probability you found is lower than 5%, then the result should be considered significant. Our percentage is 2.9, which was less than 5%. So now we can conclude that wearing socks on your boots is going to decrease the sensation of slipperiness when walking down an icy road. That was not just due to the randomization of the group. So I guess if we get another ice storm, you can test this theory out. Wear socks over your boots if there's ice on the ground, see if it helps.